Hello world! In today's tutorial, we're going to add LangSmith observability to the LangGraph agent that we built in the previous LangChain tutorial. I'll show you an example in Python. Before we start, I want to emphasize that the purpose of my tutorials is not that you code parallel to me. For this matter, I always upload the full code to my GitHub profile. You can find the link in the description below. Let's get to the point. If you haven't watched my previous LangChain tutorial, please do so because this one is an upgrade of that one. It's mandatory because today we'll add LangSmith observability to the previous LangChain tutorial. In the previous tutorial, we demonstrated how to implement persistent memory for a LangGraph agent using PostgreSQL. However, after sharing the tutorial on social media, I received feedback pointing out that this approach consumes more tokens. This observation is valid. In this tutorial, we'll use LangSmith for observability to confirm this and provide deeper insights into token usage. LangSmith is a platform for building production-grade LLM apps. It allows you to closely monitor and evaluate your LLM app so you can ship quickly and with confidence. The code of today's tutorial is 99% the same as in the previous LangChain tutorial. The only difference is that we'll use Mistral LLM instead of Anthropic LLM. If you're interested in what this code does, go watch the previous LangChain tutorial. Getting started with LangSmith couldn't be any simpler. In the previous LangChain tutorial, we set the API key for the LLM provider. The API key for the tool, Tavily, is used as a tool to connect LLM to the web, and a few PostgreSQL environment variables. PostgreSQL is used to enable persistent memory. For LangSmith to work, we need to add 4 LangChain environment variables. We need to set tracing to true, the LangSmith API endpoint, the LangSmith API key, and the project name. You can choose the name you like. I'll show you the easiest way to get your environment variables for LangSmith. Log into your LangSmith account and go to the tracing projects. Create a new project. This is where you get everything. To get an API key, simply click Generate API Key. As you can see, it's automatically applied here. To set the project name, simply type it here. Again, it's automatically updated here. Actually, here are 5 environment variables, but we will not use OpenAI. You can delete the OpenAI API key environment variable from the env file. Now, all you need to do now is copy all 4 environment variables with one click. Down there's even a snippet you can use to test LangSmith. Let's look at the core of today's tutorial. Clone my GitHub repository. Change the directory to this one. Create a virtual environment named myvenv with the following command. I will not press enter because I already did this. Now, you should see a folder named myvenv here. Activate the virtual environment with the following command. As you can see, the virtual environment is activated. Now we can install the dependencies by running the following command. Again, I will not press enter because I already did this. This command looks into the requirements.txt file and installs all dependencies with specified versions. I created a test Python script. Run it to test LangSmith. After running it, go to LangSmith, and you should see a project named Test. That's because I set the LangChain project name environment variable to Test before changing it to YouTube LangSmith tutorial. If you take a look at it, you should see one run here. I have 3 runs, but that's because I ran the test script 3 times. Anyway, here's our input, and here's Mistral LLM output. On the right, we see observability data. Our LLM API call was successful with a latency of 0.5 seconds and 28 total tokens consumed. Under the Metadata tab, we have even more observability data. What LLM was used, parameters, LangSmith SDK version, etc. Now we have the LangChain project name environment variable set to YouTube LangSmith tutorial. As I already explained, this is the code from the previous LangChain tutorial, with the difference of using Mistral LLM this time. Let's run it. First, we'll greet the LangGraph agent with, "Hi, I'm Bob." Quit the chat. Let's head to LangSmith. A new project was automatically created just by running the code with the env file set up correctly. It's that easy to use LangSmith. If we open the run and take a look at the Mistral part of the graph, we see observability data. We greeted the LangGraph agent and received a response. Let's rerun the script. We'll do this just to see that persistent memory using PostgreSQL works. Second, we'll ask the LangGraph agent for our name. Quit the chat. Let's head to LangSmith. If we open the new run and take a look at the Mistral part of the graph, we see observability data. We asked the LangGraph agent for our name and received a correct response. The LangGraph agent got this information from PostgreSQL. Remember the comment I got? See, all previous messages are retrieved from PostgreSQL and passed as inputs to every subsequent message we send to the LangGraph agent if we use the same thread ID. Consequently, the token consumption is rising with every subsequent message added to the same thread. Let's rerun the script again. Third, let's simply greet the LangGraph agent with "Hi." Quit the chat. Let's head to LangSmith. If we open the new run and take a look at the Mistral part of the graph, we see observability data. We just greeted the LangGraph agent, but look, all previous messages were retrieved from PostgreSQL and passed as inputs. Are all these necessary for the LangGraph agent to greet us back? Not. This highlights a key inefficiency. More tokens are consumed than necessary, as the LangGraph persistent memory mechanism sends all prior conversations from a given thread to the LLM, even when earlier messages aren't relevant to the latest message. As a result, token consumption increases, leading to higher costs. That's why LangSmith is useful, to observe AI apps and see what's happening behind the scenes. You can start using it as easily as setting up 4 environment variables. Ta-da! Pretty amazing, huh? That's it. Thanks for watching. If this tutorial was helpful, please like, comment, and subscribe.